Hey everybody, how's it going? This is Pat Nappy here from PNLearning.net, and I've got another video here in my series on the SAT practice test number 2. Today we're going to be looking at a question from the part 3. This is the no calculator section, so let's put those calculators away if we've got them out, and let's try to attack this problem as quickly and as easily as possible. Okay, here it is. This is number 11. All right, I'm not going to lie, this is kind of a harder question. This is one of the first questions which I would consider to be kind of hard on this section. It's going to require us to do some actual algebra here, and we're going to have to know quite a few different little things about imaginary numbers and complex numbers. So let me go over those things first, right? It says, which of the following complex numbers is equivalent to 3 minus 5i over 8 plus 2i? And it says note, I equals the square root of -1. That's the first thing. You're not going to have to know or remember because they're obviously giving it to us here. But what you do have to know or remember is that if you were to square both sides of this little fact, we're going to end up getting a statement that says I squared equals -1. This is going to be very important later on in the question. The next thing you have to know is how to simplify complex numbers. We're in a situation where we've got a fraction and you've got an I in the numerator and in the denominator. So the question is how can we sort of get it out of the denominator and make it so that we can split this fraction up into two fractions? You know, looking at all your answer choices here, you're going to see there are two fractions, right? One either adding or subtracting with the other. And that's a hint sort of that you need to split this fraction up. So the way you do that, right, the way that you can get an imaginary number out of the denominator and make it so that you can split up a fraction is to multiply the numerator and denominator by a complex conjugate, and particularly by the conjugate of the denominator. So what do I mean? You're going to take this fraction, 3 minus 5i over 8 plus 2i, and you're going to multiply the numerator and denominator by 8 minus 2i. 8 minus 2i is almost the same as the denominator, except we've switched the positive to a negative symbol. And that's really all a complex conjugate is. It's some complex expression with two terms, and you just switch the middle sign. Once you've got that down, you're going to start multiplying these things out. You're going to get 3 times 8, which is 24, 3 times -2i, which is -6i, -5i times 8, which is going to be -40i, and -5i times -2i, which is going to give you positive 10i squared. Denominator, you're going to do the same thing. 8 times 8 is 64. And now there's going to be two steps here where we actually get terms that are going to cancel out. And that's what the conjugate is always used for. It's used to generate two middle terms in a binomial expansion that cancel out. So here we are, 8 times -2i is going to be -16i, and look at the next step, we're going to get 2i times 8, which is positive 16i. And there you have it. We're going to get a cancellation there in just a minute. One more step, we have 2i times -2i, which is -4i squared. Okay, I mentioned earlier that I squared is equal to -1. So it's helpful to remember that I squared is not really a complicated thing. It's actually just -1 in disguise. And so it's going to be actually quite easy to multiply 10 times I squared and -4 times I squared. We're just going to be multiplying them times -1. For our next step, we want to start to clean these things up, right? We've got, let's see, 24 in the numerator. We've got some like terms here that we can combine, -6i minus 40i. That's going to be -46i. And we've got 10 times -1, which was 10 times I squared, and that's just going to be -10. In the denominator, we're going to go ahead and get 64. We're going to get the -16i and the plus 16i to cancel out. And we're going to get -4 times -1, which is +4. And now we're going to get just a single number in the denominator, right? We're going to get 24 minus 10, which ends up being 14 minus 46i, over 64 plus 4, which is 68. And then we're going to take this fraction apart. As long as we put the denominator 68 with each of these terms, we can split this up using this subtraction. And what I mean is that we're going to be able to rewrite this as 14 over 68 minus 46i over 68. And all we have to do now is sort of look up at our answers and see if we got it. We're getting close because it's starting to look like these answer choices, but we don't have anything that exactly matches. And we might start to notice that there are 34s in the denominator, there are 8s and 2s in the denominators, so we're going to be trying to get something like that. And the only way we're going to turn a 68 into a lower number is by simplifying these fractions. You might notice that 14 and 68, they both have a common factor of 2. If we divide 14 by 2, we get 7. Divide 68 by 2, you're going to get 34. Minus, and over here, similar sort of thing going on. If we divide both of those by 2, we can get 46 divided by 2, which is 23, and 68 divided by 2, which is 34. And just don't forget the I is there. And this ends up being our answer. This ends up being, let's see, choice C. And yeah, there's really no easy way that I can think of doing this question. You just kind of have to know how to work with complex numbers. It's not something that you probably spend a whole lot of time doing in your high school classroom. It's usually maybe something we do for like a week or two. And so for that reason, it's kind of difficult. However, if you have a good understanding of what I is, and more importantly, what I squared is, you don't have to really worry so much about this question. And you just have to remember that if all of our answer choices have 2 fractions, then we want to split this single fraction up into 2 fractions. And that's all going to happen if we can just get a single number in the denominator. And again, that's accomplished by using something we call the complex conjugate. So that's what I'll say about this question, guys. If you have a better or quicker solution, definitely leave me a comment and try to explain that to us. I'd love to know a quick way to do this one. I'm just sort of stumped here. I just sort of have to do this question the way that we learn it in high school. So if you have that trick, let me know. I'll remake a video and show everybody how it's done. But if you found this video helpful, definitely give me a like or subscribe to my channel. If you know somebody who's going through SAT prep, maybe having some trouble with complex numbers, definitely share this video with them. And I also offer one-on-one SAT prep and group SAT courses at my website, PNLearning.net. So definitely find your way over there if you think that's something that might be helpful. So that is it for this video. Thank you for watching, and I'll see you guys in the next one.